Today we'll be doing the integral from minus infinity to infinity of the arctangent of x over x quantity squared dx. And to start off, we could split the squared into the integral from minus infinity to infinity of the arctangent squared of x over x squared dx. And notice that if you plug in negative x, you'll realize that the integrand is even. So we have twice the integral from 0 to infinity of the arctangent squared of x over x squared dx. And we use integration by parts here. So we're going to let u equal arctangent squared x. But that means that du equals twice the arctangent of x over the derivative of the arctangent is 1 over 1 plus x squared dx. And that means that dv equals 1 over x squared, and v equals the integral of 1 over x squared, which is minus 1 over x. So we're going to have a arctangent squared of x times negative 1 over x from 0 to infinity. We have a 2 here, and then minus integral from 0 to infinity of v du, so twice the arctangent of x over 1 plus x squared dx. And in the limiting case, this will end up being 0. These negatives turn to a positive, and 2 times 2 is 4. So we have 4 times the integral from 0 to infinity of the arctangent of x over x times 1 plus x squared dx. And we'll make a substitution here. We're going to let j equal the arctangent of x, but it follows that dj is 1 over 1 plus x squared dx. And that means that the tangent of j is our new x, and the bounds of integration, j1 is 0 and j2 is pi over 2. So we have a 4 times the integral from 0 to pi over 2 of j over tangent of j, and we're going to have a dj. But this is the same thing as 4 times the integral from 0 to pi over 2 of j cotangent of j dj. And from here we'll use integration by parts once again. I'm going to let u equal j, which means that du equals dj. We're going to let dv equal the cotangent of j. And the integral of the cotangent of j is the natural log of the sine of j. So this is 4 times u times v from 0 to pi over 2, then minus integral from 0 to pi over 2 of v du, which is dj. And you can check that this limit also ends up being 0, and we're just left with negative 4, the integral from 0 to pi over 2 of the natural log of the sine of j dj. But the integral from 0 to pi over 2 of the natural log of the sine of j dj is a well-known integral, and it equals negative pi over 2 log 2. So using this fact, we have negative 4 times negative pi over 2 log 2. The negatives cancel. 4 over 2 is 2, and we're left with 2 pi times the natural log of 2. So now we could say that therefore the integral from minus infinity to infinity of the arctangent of x over x quantity squared dx evaluates to 2 pi times the natural log of 2. And so this is the final result. Thank you very much for watching.